A very pleasant morning to distinguished guests, eminent speaker, prominent professors present today, and our cheerful audience. Ladies and gentlemen, I, Dr. Poonam Jain, member of Executive Council, IAPTRC1, welcome you all for the online lecture organized by Indian Association of Physics Teachers, Regional Council, Delhi and Haryana. I would like to familiarize our audience with the IAPTRC1 and its activities. Indian Association of Physics Teachers, a major and well-reputed organization established by late Dr. D.P. Khandelwal in the year 1984, has local chapters in every state. IAPT RC1 is one of the chapter of IAPT for Delhi and Haryana. It has now grown into a major organization with about 6,500 live members spread all over about 1,500 organizations throughout the country, including about 100 members from abroad. The members include school, college, university teachers, research scholars, science administrators, and science savvy enthusiasts. For its grassroots working, the country is divided into 20 regions, each with a regional council. The Apex Executive Council coordinates and directs the effort at the national level. IAPT also conducts the national standard examination in various subjects like physics, chemistry, biology, astronomy, and national standard examination in junior science, national graduate physics examination in November each year throughout the India. IAPT RC1 organized various activities for promotion of physics and physics education. In pandemic COVID-19, when the world is not able to do anything, we have successfully conducted many important lectures for school and college teachers and students. We organized various workshops for the benefit of the school and college students and faculties. IAPT RC1, with various accolades to its name, has become an influential powerhouse to reckon with. From organizing various lectures in COVID pandemic situation to organizing various workshops, annual conventions, IAPT RC1 has paved its way and reached the pinnacle of successes. IAPT RC1 witnessed many achievements and successfully conducted many important events in the normal situations as well as in pandemic. Moving further, I would first like to pay my sincere gratitude towards Professor Rajmal Jain, former professor, Physics Research Laboratory, Ahmedabad, Gujarat, for gracing us with his presence on this auspicious occasion. Now, I would like to request Professor Seema Vats, President IAPT RC1, to kindly introduce our eminent speaker, Professor Jain. Over to you, ma'am.
Thank you, Puno. So it gives me immense pleasure to introduce our distinguished guest, Professor Rajmal Jain. He is an internationally acclaimed space scientist of Physical Research Laboratory, Department of Space, who has made a fundamental contribution to the development of solar and planetary physics and related instrumentation in India. Dr. Jain is one of the founders of Udaipur Solar Observatory and has been a key contributor to its growth. Professor Jain is a project director of Solar X-ray Spectrometer Mission, the first space-borne solar astronomy experiment in India. He was also involved in other missions planned for Chandrayan, Mars, and Aditya. On the other side, he has also made significant contribution to the Jainism. Particularly, he has contributed scientific aspects of Jain philosophy and canonical texts. He is a good educationist, advisor, and a counselor. He has been in good books of late Dr. APJ Abdul Kalam, former President of India, and Professor Yuva Rao, former Chairman ISRO India. Professor Jain did his PhD at PRL, that is Physical Research Laboratory, in 1983. He has published more than 120 research papers in international peer-reviewed journals. He delivered more than 500 academic, popular, and public lectures at various national and international platforms. He guided 9 PhD students and he discovered for the first time the iron and nickel in the sun employing his SOXS mission. Professor Jain visited more than 100 countries and represented India at various platforms. Now, his achievements are numerous, but I'll just enumerate few of them. In achievements, Professor Rajmal Jain is the first Asian to receive International Young Astronomer Award from NOAO, USA in 1984. He has been honored with SARC Countries Resource Person Award in 1996 by Ministry of HRD, Government of India. His first foreign visit in 1981 was to erstwhile USSR as a Prime Minister Fellow to attend international conference sponsored by the then Prime Minister of India, late Mrs. Indira Gandhi. Earlier in 1996, Acharya Bhagwan Shri Kanak Nandji Gurudev felicitated him at the national level with Saraswati Putra and similarly was honored with Jain Ratna and felicitated by Jain Munishri Tarun Sagar Ji Gurudev in Bhopal in 2012. Elected in 2012 as a Fellow of Gujarat Science Academy as well, and he received Lifetime Achievement Award from PG College from the Government of Madhya Pradesh for outstanding research, high-tech instrumentation development, and educational reform in rural India. Professor Rajmal Jain received highly prestigious fellowship from Royal Astronomical Society, UK in 2014. This award came to him in recognition to the discovery of iron and nickel in the sun. This discovery was a landmark achievement for India. Recently, on 5th February 2023, he has been honored with Lifetime Achievement Award by Sandeshwar Puram Vigyan Teerth Trust near Palitana, Gujarat, for his recognition to his extensive research work on science and Jainism. Currently, Professor Jain has been honored with Outstanding Professor Award of IPS Academy, Indore, Madhya Pradesh. We welcome you, sir, and we are so privileged to have you on this day and kindly enlighten us with your talk.
Sir, kindly unmute yourself.
I'm audible?
Yes, sir. Now you are audible.
Yes, sir.
My PPT is visible.
Sir, no, we
No,
can't
sir.
see your
My
screen.
PPT is not visible.
No, sir, please share screen. Then it will be visible.
Just a minute. Now you have to give me a time, okay?
No problem, sir. No problem. So just like the previously, you have shared the screen.
Yeah, but now because
Sir, a green color button in the bottom panel, share screen.
I know that.
Yes, sir.
Maybe there is some problem. I am audible, right? Hello, I am audible.
Sir, you are audible.
Okay. Can you see screen now?
Yes,
Yes,
sir,
sir.
it's perfectly fine. Sir, make it full screen.
Yeah, I think now it is full screen. No.
If you go to the slideshow, sir, it will be full screen.
Yeah.
Yes.
I'm going to slide show here only.
Slideshow at the top, sir.
5.
Sir, upper tab, slideshow.
Yes, I know that, but
Slightly go up.
somehow
Sir, from above also, the slideshow button in the top panel.
you have slideshow in your also.
Top. Slightly
Sir,
go up, sir.
above. Sir, where is your cursor? Just go a little above.
Till above.
Sir,
Still more.
you are getting the tabs now. Home, insert, design,
I
transitions,
have
presentation.
your tabs only this much.
Slideshow is slightly up, sir.
Yes, sir. This button also works. Yes, sir. Where is your cursor in the bottom? This also works.
I
Yes,
hope
sir.
it
It's
should be okay
yeah.
now.
It's absolutely fine, sir. You may
Okay.
start
Yes.
now. Yes, sir.
Okay, thank you very much. At the outset, I'm thankful to Professor Seema and Executive Committee of RC1, IAPT. I'm going to talk about this India's big leap into the space. The whole India is has a proud on Indian Space Research Organization, ISRO, in general since last few decades, but particularly since last 2 to 3 months. But many of you might not be aware, and particularly young students might not be aware that when we established this Indian Space Research Organization in 1969, and even before that, when Pandit Nehru was given an appreciation by Dr. Vikram Sarabhai to establish ISRO, then he refused in the beginning, and this happened in the 1948 when this physical research laboratory was inaugurated by Pandit Nehru. And he told that why we should go to the space when India has so much, problem of population, GDP, there is a lot of, literacy problem, then there is a lot of poverty in India. Whatever the data which I am showing, of course, the data of present time, but the same things, similar kind of, I mean, uh, talks were described in PRL by Pandit Nehru to Vikram Sarabhai. And even if you compare our India relative to the over the globe, then you can say that the large population, almost 18 to 20% population of the world, and only 2% the land is there. There is a very, very thin forests are there, hardly 1.4%. And we have no, power generation systems. There are a lot of GDP issues, etc. But still, Indian Space Research Organization was finally given a consent by Nehru, and then Mrs. Indira Gandhi formed it as a formally. Why? Because Dr. Vikram Sarabhai told only two things to Pandit Nehru. He told that, see, this will help to prop our property on the land, in the air, and below the surface, as well as this will enhance our communication capabilities, what we call nowadays remote sensing capabilities and our communication capabilities. This exploration to the universe came much later. But these two things, these two powers of remote sensing and communication convinced to Pandit Nehru as well as to Mrs. Indira Gandhi. In 1969, finally it was established. But you all will be surprised, dear friends, to know that when ISRO came into the existence, there were no facilities. Even no country in the world was ready to give any kind of technology. There were no roads. And so, whatever we started, the whole thing was forming, the building of the rockets with the technology of Tipu Sultan, whatever he used at his time. And there were no roads. Even the rockets were being taken from Trivandrum to the launching site in some kind of a church place on the cycles, by walks, on foot. And even the satellite, when I had already joined, the satellites were being taken on the bullock cart. That was the time. So we started our whole technology innovation, technology development with such kind of conditions. No money was there even to get good salaries. But thanks to Mrs. Indira Gandhi, who brought many people, including me from USA, and we all joined ISRO. And today, what you see, one after other, many satellites, many rockets were first developed and empowered by India. In the beginning, people were laughing, not only in India, but all over the world, when the rockets were being failed one after other, one after other. But there was a political will, there was a technological will. We all were determined, and finally, we succeeded in building the not only the rockets, but the required items such as fuel. And particularly as on today, we are master of the solid fuel in the world. We are master in the polar space launching vehicle PSLV because we went employing this PSLV all the way to the moon, and now we are going for the searching, exploring the sun. Today, dear friends, I will talk about the moon mission program of India and Aditya. So what I will do, because two different topics, so I will briefly discuss this about the moon and Aditya. But whenever I promise to all of you, whenever I will be in Delhi, at least one dedicated talk I will give about the Aditya, because that is my favorite subject. I think there is some recording problem. Okay, I'm audible. Hello, I'm audible.
Yes, sir. Yes.
Yes, sir,
Very
you
much.
are audible.
Okay, thank you. So we started, you see, the moon mission. Once we were ready with the technology, then we thought at least now we have already have a control for remote sensing satellites. We have, already explored our forests properties, our animals, our farming, agriculture properties, etc. At the same time, we have already enhanced enough now our communication facilities, and we can explore now the space also. So we thought at least we should go to our nearest celestial object, that is moon. And so we formed some questions, with some kind of a brainstorming session within the ISRO, and we came that, okay, first of all, we should address the question related to moon itself. What is its origin? What is the process of evolution that moon had? Related to the sun also, that interplanetary space, whatever the particles, whatever the and spreads all over the interplanetary space, but how it interacts with the moon. Related to Earth, whether Earth-Moon relationship, moon came out of the Earth or it was during the formation time itself, it was a separate object. Then the major, in those days, in 2008, a major question was there that what we are planning to do, what we will do, something new, because ISRO is known that we don't want to do repeated things. We always want to have some innovative thing, whatever the limitations are there, but with our those limitations, what we can contribute something new to the world. And so there was an idea that we should explore the water possibility of the water existence on the moon. And that was the main. But as I told that as a function of time at every stage, there was always some kind of a resistance among the people, among the politicians, and of course, all over the world also that why India, a developing country, should go to the moon, etc. Then in order to respond and to connect the people as well as politicians, we made a small video. Okay. And before that, I would like to say we shared with the politicians as well as to the people like me and as well as in us, all scientists went to the universities, schools and told that there is a debit of the moon, debit of the moon on the earth, and we should understand what is that debit. You know that at the time of the formation of the moon and earth, almost even up to 2.5 billions of years, the moon was actually very, very close to the earth, very close to the earth. And the daytime, that is what we have at the moment of 24 hours, it was hardly 6 hours a day. And because the moon was very close, so our this gravitational pull, and as a result, the tides were so much on the earth. So the oceans were always thundering, like big tsunami waves were being generated, and of almost of the 32 meters to the 100 meters of something like that. And as a result, there was no evolution of life near the oceans. And until unless the life is generated near the oceans, it is evolved over there, how I mean the bigger and bigger creatures will develop. But thanks to the God, thanks to the moon, who really played a role of a brother to the earth. As it, you know that the earth has various kinds of motions that moving around the sun, that is orbits around. And at every time, you might have heard about Milankovitch cycle, but every time there was a differential gravitational pull. And as a result of that differential gravitational pull, in order to balance, the moon was moving away hardly 3 to 4 millimeters per year, 3 to 4 millimeters per year. And that was some kind of a debit that moon decided to move outside in the space, and slowly that in few millions of years when the moon was significantly away, then the waves actually came down and slowly microbes started to develop near the ocean. In billions of years, this life started to evolve near the oceans and then spread all over the earth in different forms, including the dinosaurs just 65 million years back. And after their death, the new human society actually developed what we are talking today. So as of now, slowly moving, that movement of the moon kept the moon currently at a position of 3,84,000 kilometers away from the earth. And still it does not mean that it is not moving. Now it is stationary. Still it is moving away from. So starting from the 6 hours day, currently we have 24 hours day. And after maybe billion year, we may have the 28 to 30 hours day also. There is a possibility. So what I wanted to say, we shared this story, this scientific truth to the people who at least were literate and able to understand. But in order to make understand the general public as well as politicians, I told that we made some kind of a movie starting from the beauty of the woman, and we told that moon is compared in our the canonical texts as the beauty of the woman. And not only that, we told that irrespective to race and religion, caste and creed, we always use the moon only. Wherever the child is born, irrespective to the race and religion, caste and creed, the moon is only used for the horoscopes. So as soon as this video became popular, the parliament cleared our proposal, and we framed out our science objective and the equipment, payloads, etc. for the Chandrayan 1 mission, which was launched, you know that, in the 2008. So there were terrain mapping camera was there, and hyperspectral imager. I mean, many instrument, including the moon impact probe, uh, with the motivation of Dr. Abdul Kalam. And we introduced that almost you can say at the last moment, but it worked very well. And then Chandrayan 1, these X-ray spectrometers were there, both low energy and high energy. And then infrared spectrometer was also there. Sub keV, this atomic thing analyzer, that SARA instrument was there. Then moon mineral mapper, that is MCube, was also there. Charged particle radiation dose monitor. So with all these instruments, the Chandrayan 1 was launched. But dear friends, I would like to share with all of you a very important conclusion, decision which was taken by the ISRO scientists and with the government of India at that time, that we included the payloads of those countries also, which refused at the time in the past even not to give a small point of technology. No technology, nothing. But now they came to us and we told, okay, we will, carry your instruments also. So this is the greatness of our Indian tradition and culture. So you know that the moon impact probe, finally it was dropped from Chandrayan, that orbiter mission. It was so managed very well that at precisely at the location where we wanted, that it dropped, and particularly on day 14 November, the birthday of Pandit Nehru, and that place where it dropped, its name is now known as Jawahar Sthal. And this instrument told us that there are some symptoms. There are symptoms of water, and all other instruments should probe the water. It was not only that, but our terrain mapping camera, it actually really located. It located largest crater of almost of the size you can say in November 15, few hundreds of kilometer, almost 170 kilometer wide that crater. The diameter itself was observed that this crater actually, as well as terrain mapping camera, also discovered the uh, big tube, that what we call in our India as a tunnel kind of thing. And that was a big discovery for future. I mean, what we want, that human exploration or how we will protect them. so that tunnel can be used to save the humanity from the radiation, from the other kinds of diverse conditions, etc., on the moon. So actually, Chandrayaan 1 made big, discoveries, including the water. This is one instrument which I would like to say. Of course, it came from USA. It is known as Moon Mapper, Moon Mineralogy Mapper, and what we call is generally MCube. But this was orbiting as a function of the latitude of the moon from north to south and then south to north, and it made many kind of mineralogical mapping, then temperature mapping, albedo mapping, and then this what absorption, which was the most important part. Now, this whatever the different on the left side you see, the maps are of those different uh, the instrument specifications in different wavelength. If you know the spectroscopy, many of students are aware of that. Then what instrument did, not only that, but also that in moon impact prop, as well as in the other instruments also, when the spectroscopy was done, then we clearly found that there are, yes, symptoms of hydroxyl, that OH atom, as well as the H2 also. So both I have shown in this as a function of wavelength, the intensity or the spectrum concentration. So you can see that this was a clear cut signature of the existence of water in one or the other form. Then there were other instruments which I told you. They found, they found that, say particularly Chase was the one instrument. They told that on the sunlit side of the moon surface, below the few microns, there are signatures of the ice kind of a system. And that I was also discovered and finally told that, yes, there is a chance of the water. However, a clear cut that water is in the liquid form, solid form, or in the gaseous form, or in the ice, in the frozen, in the craters, etc., that was supposed to be done. And that is what the aim was of Chandrayaan 3. Well, dear friends, in addition to that, as I told that there were a lot of, these craters, big craters were there. Some MSc student, Kushal Bhatt, one day he came to me and he told that, sir, can you give me some small project work which I can do using this space-based data? Because nowadays that old data from which brought by the Apollo, etc., is old now. I want to. So I told, okay, because you are doing MSc, still MSc student, you may have very little time, but you can, what you can do, I gave him a formula, and to calculate that based on the diameter of the crater, the depth of the crater. That was in something new, that based on the diameter, the depth of the crater, because there is simple physics that diameter can give you the idea that this crater is caused by which kind of material. Generally it is asteroid, comets, meteorites, etc. But that meteorite or comet is made of which element? Say, for example, the iron or nickel or copper, or it is silicon based, or the some tungsten kind of things. So as a function of density, the crater depth is generally known. So if you know the depth of the crater, then now in the inverse way, you can find out that crater is composed of which the density material. So this paper which he did, and what he found is a scaling law. It was wonderful. This paper is very popular in the whole world. He found that this depth, whether it is north side of the moon or it is a south side, but depth of this is directly proportional to the diameter. And he found that on the latitudinal scale, the north, south, and at the equator, large number of craters are there, while on the longitude side, mostly the craters are at the near the equator, at the center of the moon. So this only I wanted to share for the students to motivate them that if you want, you can always do some good quality of work. Now, this we came to the next Chandrayaan 2 then, and then it was thought that, okay, this time, in addition to the orbiter, we should land on the moon, and on the moon at the site where there is a possibility which was explored by Chandrayaan 1, that is the south side. And during the, where the, you know that the moon lunar day is of about 27 or 28 days. So 14 days day and 14 days night. And particularly, there are many surfaces of the moon which never see the sun at all. The maximum part of the moon which observes the sun is only 54 to 55%. Rest of the moon remains only in the dark. So we wanted to go to the dark side, but as well as sometimes it can see the sun, and that is in the south side, where it was, possibility was explored that lot of water should be minerals, etc. So of the sun, which is that is observed from the moon to the sun. And then, so that was a great motivation failure of lander of Chandrayaan 2 for the development of Chandrayaan 3. So Chandrayaan 3 basically is not a, I should say, a scientific satellite, but it was only technological mission. That is the failure part of Chandrayaan 2. I do not hesitate in telling anything. We should always accept our failure, and we should learn from our failure and go ahead how to we can make that failure as a success. And that is what the whole story is Chandrayaan 3. So in Chandrayaan 3, basically, we want to demonstrate only the safe and soft landing on the lunar surface, but at a particular place near the south side. And to demonstrate that the rover comes out from the this lander, and then it rolls on the surface at our desired location, and then it does the scientific experiment. So far, you know that there were some payloads on the lander. So these are the payloads on the lander. There are many Language probe and many other instrument to take the photographs, etc. I would like to mention here that, in fact, nobody in the world, nobody, no scientist in the world was aware that there will be such a, extreme temperature gradient will be there. And even particularly on the southern side, where the most of the time also at 50% time, the night is there. And that is what the temperature has been observed by the chassis, that the temperature gradients are very intense. Just in few microns to millimeter below the surface, it is minus side to the plus side. It is almost more than 100 degrees centigrade. So this was the first kind of an information, and this information is so precious, so important for the future planning of our habitation on the moon, etc. Such temperature gradients will be always dangerous. Then similarly, there were many other, I will just briefly tell, these are the instruments. And then there were two instruments on the rover, and one instrument was on the propulsion module, which from where this lander got separated. So we made actually use of Chandrayaan 2 cameras also to see continuously the tracking of this lander, as well as the propulsion module also. We used its very perfect, potentiality to map the things, as well as what we can do in the future related to the smaller planets are existing over there. Say, for example, I told that the lots of craters are being, the moon is always impacted by the meteorites, comets, and other asteroids, etc. So which one may be the more safer side, keeping in mind that what we published the paper also, and what are the, areas, what are the areas where we can find the, precious elements, etc. So what I can say that I think this was the movie, oh, sorry, that when the rover actually came out from the lander successfully. This was a great actually movement, a matter of pride for all of us that everything worked very successfully. You can see okay. Basically, I think you all might be having questions in mind. So finally, why we want to go to the moon? Even as on today, you may ask some question. And the basic question is related to not only the instrumentation development or only show our technology power, but keeping in mind that whether can we use moon. Please underline my this sentence. Can we use moon in the future to, I mean, for launching our satellites from the lunar surface itself? Can we learn from them because that will be less expensive? And can we explore from that distant planets, etc., celestial objects? On the other hand, industrial people, they want to exploit the helium if it is possible, because helium is a big energy source. And transportation capabilities, building houses, and then the human civilization. Some people want to go as a tourist. They want to make the moon as a tourist place over there. So a lot of things are there. And people also want to do that, whether small, I mean, that what is still others see the moon as a potential site, as a home for the humanity. But is it possible in next 50 years even? So recently the ISRO made our 50-year the plan, that is the plan map, roadmap for the next 50 years, in which our new missions to the Venus and Mars are also in the pipeline. Anyway, what has been done by the Chandrayan 1 and Chandrayan 2, and that was some kind of a water map. And you can see in this picture that on the right side, all the blue dots, what you see, that is of few hundreds of kilometers each one, is the pixels. That is the moon mineralogy mapper and other instruments which made the water is there. So lots of water you can see over there. If water is there, then why we are not able to discover so far? That may be the big question. Oxygen has already been discovered. Hydrogen should have been discovered. But the other instruments, not only Indian instruments, but by the other instruments of the other countries, have also discovered the signatures of the presence of H2O, that is a molecule, OH also, iron as well as atom also. So a lot of water is there, but there must be. It means some scientists at NASA, as well as the like person like me also, they say that if there is a water below the surface, in the subsurface of this lunar surface, at the I mean, South Pole as well as the sunlit side, means always whenever there is a water, signatures of water exist, means some virus, some microbes should always be there. And once this life exists over there, then only you can expect the evolution of life in the future also. That same story as the earth also had in the very beginning. So I think this is the right time now to advocate, to recommend to the ISRO, and ISRO must take now the space biology, astrobiology as a new now features, new subjects for exploration of life in the space. Already ISRO has started the space biology program, and but not only for the moon in the beginning, but for the other the planets, what we call as a habitat planets in our this whole galaxies and other places, etc. Anyway, so this may be the one new program. Now, so far, the Chandrayan 3 already has discovered the this on the South Pole side already that some temperature problem that which I told as a temperature gradient problem, then the sulfur discovery of sulfur was confirmed on the moon south pole, and that is very good symptom that yes, other elements, not only the precious elements, but the life-saving elements are there. And the list of the elements which have been discovered so far by Chandrayaan 3 by the rover, both the payloads I have listed down also. Now, vibrations have been observed, and that says that small minor earthquakes are also exist on the moon. So that is another kind of a living, I should say, the moon is living in a planet. Then we have a plasma environment, that is what solar wind is coming from the sun, and that can be also sensed over there. Okay, so with all these things, what I would like to say, and of this first part of my talk today, I have taken, I think, more than half an hour or so. Now I will go to the next mission, Aditya L1 mission, and I hope all students and everybody will appreciate this effort of this. So before I just say a few words about the sun and that, I would like to share a video of the sun with the real observations from the Solar and Heliophysical Observatory, the SOHO mission, and you would like to appreciate that this is the some kind of a location taken by the satellite at the New York Times Square in the USA. And from there now we are sitting, you just imagine that we are sitting in a satellite and we are moving up, up in above the surface of the earth. So this is whole our earth. You can see the blue side of the earth, which are the oceans. You can see the other greens, forests, etc. You can see the clouds and all that. So this is the real picture of the earth. And you always know that the moon goes around the earth. And when the moon comes with in front of the sun, then always total solar eclipse takes place. So this was the eclipse. And I would like to have your kind attention, dear friends, to see these are the real images of the sun which have been animated, and you can see the real face in the helium line as well as in hydrogen line. So these all bright areas are the high temperature active regions. The sun has the splitted the sunspots, which are the magnetic field regions. And so connecting these are the bright loops. Can you see the lines of forces filled up with the plasma connecting from north to south? And I would like to have your kind attention at this place where you can see the high temperature fluid, that plasma. So basically the sun is, you can see that this looks like some kind of a fireball. Really, it is a fireball because at the center of this sun is 15 million degree K, that much high temperature is there. And as usual, it is also a star, and all stars have the fundamental element as a hydrogen. So at this high temperature, this hydrogen is being converted into the helium. That is a thermonuclear fusion reactions, because 15 million degree K temperature is there. So from there, at this high temperature, once the nuclear reactions are set up, then the gamma ray photons and other neutrinos, etc., they release and they come outside. Now you know that the high energy photons, they interact with the nearby existing material or plasma. That is because at this high temperature, everything is plasma. So that is ionized gas. And they interact and they lose their energy and give their main energy to the next photon, that is next material. So it is a continuous reaction and energy transformation is there. And at every transformation, the radiation is there. So the level that all these photons travel, that is known as radiative zone. Once that energy of through the radiation, it is finished, but still heat is there, and that heat is being transported like what we boil the water, that is in the form of the convection. And so convective bubbles are there, that and that heat is transformed from the bottom of the convection zone to the top level. So that whole zone is known as convection, and at the top of the convection zone, it is known as photosphere, a few hundreds of kilometers thick, and that is the photosphere. That is the actually sun, what we see in the sky. So what we see in the sky, that sun is the photosphere and not the inside, the internal story, that whole atmosphere inside, they are different, and outside atmospheres are different. So above photosphere, basically another actually colorful atmosphere is there, that is known as chromosphere. And above that, whatever you see here, that is corona. So sun is actually a multifaceted star where you can see all these phenomena. You can say it is a cosmic laboratory. You can say that it is a Rosetta Stone laboratory. It gives so many important, it is a mathematical laboratory, it is a plasma laboratory, it is a physics laboratory, etc. And it gives so much immense of information to us. But sun has a very different story. Sun is not a solid, and sun does not rotate as a result in a solid form, just like Earth does. In 24 hours, it rotates, but rather the sun basically the sun rotates as a function of latitude. So at the center, the sun rotates on this equator around the 25 days, but at the function of latitude, it moves slower and slower. So at the higher latitude, say, let us say 50 or 60 degree, it rotates in 30 days. And even at the 90-degree, that is at the poles, it rotates almost in 36 days. So as a function of this, rotation of the sun as a function of latitude is known as the differential rotation. It is not a solid rotation, differential rotation. Now I told you few seconds before that the whole heat is coming from the beneath, that is from the convection. So convective flow is coming from the beneath, and then the rotation is different. So that whole heat is distributed as a function of from the north to south, number one. Number two, because it is a plasma all the way, right from the core to the even up to the corona. But what we can see, because it is a whole electric body, and as a result, so the magnetic field at the perpendicular side is produced. So it means this differential rotation, that convective flows both generate the magnetic field that north and south of the sun. And this, what happens, I don't know whether you can see to me or not, but can you see this rubber band in my hand? Can you see rubber band in my hand? Is it okay? Can you see rubber band?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Okay, very wonderful. Just I want to demonstrate how the things happen, how these magnetic fields are generated, small from the poloidal magnetic field of north and south. You can see that the sun rotates like this. And as I told at the equator, it is always faster. So in first rotation I have done, can you see in the first rotation itself, there is a note on the one on the north-south and the one in the south. Can you see that? Yes.
Yes, sir.
And in the second rotation, the second note is there in the third rotation, but the notes are coming down towards the equator, not going up. So and these notes, what are these notes? These notes are nothing but the magnetic flux. That is number of lines of force per unit area when they are formed in such a way that magnetic flux becomes stronger and stronger, then it splits up. It splits up from the main line of force, that is north to south, extending from north to south. And that split up part is nothing but they are known as the dark sunspots. So this, whatever you see this over here, the sunspots, they are the dark sunspots. Now there is a temperature story, that from the center, I told that 15 million degree K temperature, and it comes down all the way. You can see that where in this picture temperature is written, and there is a level or layer above the photosphere and below the chromosphere, which we call as a temperature minimum condition, where the temperature is hardly 5,800. The temperature at the photosphere is about 6,000, while inside in the radiative zone, etc., it is a millions of degrees and few thousands of degrees. But unfortunately, what we see that the temperature from the core center of the sun, it is continuously coming down to the temperature minimum, that from million degree to the only 5,800 degrees. But I would like to have, dear friends, your kind attention that the change in the profile of the temperature, that as we go above and above that is outside of the sun, the temperature is further increasing. It increases to almost 10,000 to 100,000 in chromosphere, and even in transition region, that is the transformation, the layer between the chromosphere and the corona, it becomes of almost 1 million degree. And surprisingly, surprisingly, in the corona, it becomes even the 500, I mean, almost 5 lakhs, even to the few millions of K. So this is still a mystery. It means there should have been some kind of a understanding to improve our understanding. The process, what is the physical process? What is the mechanism of increase of this temperature suddenly outside, where there is radiative force is there, gravitational force already almost by and large finished, and now there is no another mechanism which can enhance the temperature. So what are those mechanisms? So Aditya mission is basically also will address this important question, this is which is a mystery so far. And similarly, and on the other hand, in contradiction to this temperature enhancement, the density as well as the pressure, they are coming down continuously, they are coming down. So the chances from that physics point of view, that is the equation of state, it was very difficult. But there it means something is happening inside, either in the corona or at the chromospheric level or at the photospheric level, that radiation is continuously coming, and that enhances at a certain distance this temperature. Anyway, I told you that about this story of the formation of the sunspots. Now, this sunspots, even a small sunspot is of the size of the Earth. Just remember, because on the diameter of the sun, you can accommodate 109 Earths only on the diameter of the sun. But if you consider, dear students, you just consider that the sun is a spherical football, okay? And if you are able to drop the Earths inside, then you can accommodate 1.3 million Earths inside that football. So sun is by volumetric way measurement, it is 13 lakhs times to the Earth. So, I mean, there was a time when the sun was little smaller. At that time, on the diameter, the Earths were being accommodated 108 Earths. आपको पता भी होगा हमारे जो माला गिनने की होती है उसमें 108 मणका होता है उसके अंदर. The bits are there, and this sunspots, you see, they have the umbra inside there where the strong magnetic field is there. Outside, when it comes, then it is a penumbra. Every sunspot by and large has northern polarity and southern polarity. There are independent also polarity regions, poles and small satellite sunspots. There was one student long back, Schwabe, and he calculated the number of sunspots, and as a function of time, their variation, and he found that there is a 11-year sunspot cycle is there. And that 11-year sunspot cycle, known as Schwabe cycle, and over the last two, after the advent of the telescope with Galileo, his number of sunspots now are being measured and last from 1750, more than 200 years now, very well, managed and have been counted. And it was demonstrated that the sun has a cycle of 11 years. Now, in addition to the 80-year and that 11-year cycle, 80 and 200-year cycle, Gleisberg cycle, my one student who did PhD, Professor Nipa Bhatt now, she's professor, she found that these two cycles 80 years and 200 years cycle, they are related to the, impact on the earth that is related to our climate and our earthquakes or volcanoes and many effects related. But during the last 20 years, another important one feature which was discovered, that you can see just on the my right side plot, that the sun is losing its this dipole magnetic field strength, and this is a big mystery again. And so in order to understand what, whether it is real or it is only for a time being, and what we call all these 11-year cycle, we have given numbers. So last three cycles, four cycles, cycle 21, 22, 23, and the last cycle was 24, and the currently cycle 25 is in progress. So it is only periodic phenomena, or it is sun is really losing. So sun is as a star, sun as a star. Now some changes are going on or not. So all those things are important to address. So we wanted to have a continuous 24 hours observations of the sun. So we chose this Lagrangian point L1 for the Aditya. On the other hand, as I told that NIPA, what she discovered based on the last sunspot cycles and the phenomena took place, that when there were gaps and this 11-year sunspot cycle lost its cyclicality, that is the no sunspots were visible for almost not for 50 years or even for hundreds of years, then at that time the earth actually faced the snow, ice age, you can say big ice age, little ice age, etc. And now we see, on the other hand, the global warming. Although it is a real global warming or not, we don't know, because 0.5 degree is not a significant warming. So what we have, so there was a question. There was a big question in last 100 years, that whether it is the sun which is culprit or it is somebody else is the culprit. What we have from the sun is radiation, and that is irradiance from the sun is known as total solar irradiance, TSI. On the other hand, what we receive on the earth is galactic cosmic rays. And galactic cosmic rays are of very high energy, and many times even they reach all the way up to the surface of the earth and even to the oceans. Why? And their footprints we can find. Also, it was discovered just 40 years back that the galactic cosmic rays play a significant role in the formation of the clouds also, and they change the atmospheric chemistry. So now there are two potential candidates. One is the total solar irradiance, the other is the galactic cosmic rays. You would like to see that whenever the sunspots are very high in number, what we call as a sunspot maximum time or sunspot maximum year. So whenever the sunspots are very high on the sun, then the magnetic field of the sun is on the higher side. And as a result of that, the magnetic field around the whole sun, that is the heliosphere, what we call the heliosphere, is also of the strong magnetic field. Now the galactic cosmic rays, that whole war, that river which flows from the galaxies, all that high charge particles, including the muons, etc., gamma rays and all that, but they are stopped by that magnetic field, because we know that the charged particles cannot flow, cannot penetrate inside the strong magnetic fields. So at that time, it means the galactic cosmic ray strength or their flux is at the minimum side. But however, on the other side, when the sunspots are at the minimum side, that is at the 11-year cycle, they will come to the minimum side. At that time, the heliosphere becomes weak, and at that time, galactic cosmic rays penetrate all the way down to the earth, even to the oceans, and even in the surface where the silica is there. So what happens? At that time, we could demonstrate also by the neutron monitors measurement of the cosmic rays, as well as on the other hand, the sunspot cycles. The top is the sunspot cycle in different sunspot cycles, and at the bottom, you can see that the variation of the galactic cosmic rays. You can immediately see that both are actually opposite in nature to each other. That is, whenever the sunspots are at high level, maximum level, the galactic cosmic rays are at minimum level. And Similarly, it means they are inversely proportional to each other. And this has been now very well established. It means there should be some effects on the Earth by the sunspots, while at the other times, the spot influences on the Earth should be governed or controlled by the galactic cosmic rays flux. However, still, we have to understand the influences by the galactic cosmic rays as much we have understood better about the total solar irradiance. You can see here what I'm showing as very important result which has been demonstrated that the sunspot cycle is almost, and on the other hand, the sea level, the sea level is varying in few millimeters, of course, but it is because that is in few millimeter also makes the large volumes of water, and it is in tune with the sunspot. It means whenever the sunspots numbers are very, very large, it at that time the sea level rise also is there. So this is one signatures of the sun, a plasma body or a radiative body has been observed in the oceans, that is in the hydrosphere. On the other hand, below the earth, from where what we see as a result of tectonic plates, the earthquake comes. Now, one is the space, the sun radiation coming from the space, but this thing is from the beneath almost 50 kilometers to 100 kilometers, or even up to 1 kilometer, the earthquake comes. But it has been observed, and my one student, Sneha, she is doing work uh, considering the earthquakes and all these radiative forces which are visible uh, related to earthquakes as well as volcanoes. And one preliminary she found that all the big earthquakes on the Richter scale of more than 5, they actually take place when the sunspots are on the minimum sides. That is when the sun is at the minimum. It means who is responsible? It means total solar irradiance is not significant. It means either the galactic cosmic rays, they are responsible, or something else, because earthquakes and volcanoes are basically considered as a result of the collision of the tectonic plates, or they are moving away from their location, and the friction force which becomes the slower down. So we have to understand that physical mechanism. If it is how the galactic cosmic rays, if responsible, then how they can reduce the friction, whether eddy currents in the atmosphere as well as in the sigma, that is muons in the soil, which is the, very soft soil like sand, etc. They are responsible over there, but no clear-cut understanding is there. Similarly, you can see the sunspot cycle in the red, and at the bottom, close to the sunspot minimum, the all and volcanoes we have understood little in a better way that they are occurring near the sunspot minimum site. You'll have seen, we have already noticed, in last 50 to 60 years, the increase in the natural disasters. And what we have seen on the other hand, the large sunspots are also coming down and down, down and down, slowly, slowly in last 3 decades. So what is the real sun he wants to show us, whether in the future the sunspots will be at the low side, maybe temporarily they are keep on coming and going down, but as longer trend, they are keeping coming down. On the other hand, my student who has finished his research work and submitting his thesis now in this year, we studied the oceans in the Gujarat. You know that the Gujarat is only the state which is largely covered by the oceans. It's a 3/4 area is actually the boundary is of covered by the oceans. And so we studied all the oceans particularly. I'm showing here only the one very important result, that the sea level is continuously increasing. And there was a Chokdi village in Khambat ki Khadi. There was Cambe that in the Indian Ocean, or what we call as the Arabian Ocean also. And the last 40 years of more than 40 years data from the Landsat US satellite data, and he analyzed the remote sensing data, and we found that the one small village that almost the water has come and very close, and many small islands which were there, they already submerged inside. It means all these things which when they took place, when I was doing work and I was invited from Udaipur to the PRL Physical Research Laboratory back to undertake, I mean, the instrumentation to develop some kind of a instrument for the after the good command on our rockets and when India decided to launch the satellite. So I told that okay, and Dr. Abdul Kalam gave his blessings, and I told that we would like to go for solar X-ray spectrometer SOX mission on the GSAT-2, which was supposed to be launched in 2003. Professor Seema asked me to share at least one more story or something, some story. I would like to say, madam, that I decided at that time as a principal investigator to fly the two important, the new generation detectors, silicon detectors and cadmium zinc telluride detector, which were never flown in the space by any country, by any country. And I thought I will anyway. People denied also, but I thought, okay, I will take the risk to fly. But unfortunately, in 1998, after when Dr. Our Atal Bihari Vajpayee Sahib, he was prime minister, and there was a nuclear explosion, and India came under sanctions, and nobody wanted to give the sensor detectors to us, to India. Then it was only our president, Dr. Abdul Kalam, who was not president at that time, he was a defense chief secretary, and he motivated to build the whole payload, including the detector development, etc., in the physical research laboratory. And we did that, and on time we launched our satellite. These are the just to show to the student and motivate them. If you have zeal, then you can always make a very small miniature kind of a payloads, detectors payload. I have put up the pen over here just to show you the measurement of the whole detector payload. The small collimator which you can see here is the silicon pin detector. The longer one is the cadmium zinc telluride detector. These detectors were flown, however, packed in the hermetically T08 package, and the electronics was made in such a way that these detectors, field of view, always see the sun, even because it was on GSAT, that geosynchronous orbit at 36,000 kilometers. It was launched perfectly and precisely.
Great achievement, sir. Fabulous.
So it was precisely and perfectly launched also. It was orbited. And I'm proud to say this was the first spaceborne solar astronomy experiment of India. And and you can see that what we observed in the high energy side. I would like to a similar kind of Soho, which images which I showed. These are the sunspots, and covering the disk of the sun, we can see that in extreme ultraviolet X-rays, the explosions on the sun, the coronal mass ejections, what the blasting, bomb blast takes place. And basically, the main objective was when scientists, our Dr. Kasturi Rangan and Professor, you are asked what exactly Rajmal you want to do. I told that we want to discover, sir, as per the tradition of ISRO, something new on the sun. What? I told iron and presence of iron and nickel, how you will do. And this is the way that the X-ray, our payload showed as a function of time, you can see the intensity. These are the time profiles, different colors are in different energy. But this was the basically a spectrometer SOX, and it was working in 256 different energy channels, 256 energy channel. I would like to motivate the students that this every picture was that is spectra was being made in 100 milliseconds. So 256 observations in 100 milliseconds. The instrument electronics was so fast, and everybody became happy when the instrument discovered at the time of the explosion, at the time of the high temperature in the solar corona, the iron at the 5.8 keV and the nickel line near around the 7.9 keV. You can see at the bottom this thing that the intensity is a function of the energy that is known as the spectrum. And as a result of recognition of this, I was invited by the Royal Astronomical Society with the nomination by the top people, and I received the fellowship of Royal Astronomical Society in 2014. So this are the really some kind of thing. There were many questions left over at that time because this was the only one payload thing. So it was decided by Professor U.R. Rao that, okay, now India must go for a dedicated mission to the sun. Now there was a question that dedicated means all the instruments should see 24 hours sun. And that was the point, Lagrangian point. I will explain a little later. So there were many, many instruments which have been planned. You can see that the VELC, that visible emission line coronagraph. So we wanted to see that the really coronal ejections or the lines of force which are extending outside. I showed in the video in the beginning those lines of force, how they evolve outside. So that emission line coronagraph will see, then the ultraviolet imaging telescope will see even the below the photosphere also, and see the small, those brightenings, which are the potential sites for the coronal heating, the mystery which I told, and small micro flares, etc. And then theoretically, we can do even magnetohydrodynamics. And similarly, we can measure the magnetic field. But this time, because at that time, before my retirement only, this was planned, and I was asked, Rajmal, can you contribute some instrument? So I had proposed the Swatis. Swatis means solar wind and suprathermal, this ion spectrometer. This time I wanted to make use of different instrument and as well as the silicon detector for the particle detection. So this later on after my retirement, it took the even the little change in the format. And currently my colleague, Professor Dibyendu Chakravarti, he is the in charge project director of this ASPECS director. Its name has been changed. And so many instruments are there, including my one colleague, Dr. Satish Thampi at Vikram Sarabhai Space Science Center, that is Space Physics Laboratory. And he made that plasma analyzer for the particles, Aditya, that Papa instrument. These are the various instruments and various institutes which are involved. You can see the highlight in the yellow color and blue color, basically where we actually got involved, and the proposal was formed. Sorry. Now this instrument, we will see how all the instruments will work sometimes in January, and I will get back to you in January when the instruments are working and we get large sample of data. What is the Lagrangian and why we want to go to the Lagrangian point? So you can see the sun here, and you can see that the Earth actually here is orbiting around the sun in elliptical form. And this ellipticity of the Earth does not remain the same and same. That is what I want to say. Eccentricity of this elliptical orbit is keep on changing at every 100,000 years. Now, within a given time of frame of few tens of years, we need not to worry. And the near this, between the Earth and the sun, there is a line. And at that line, in between that, there is a point. And similarly, if you go at different positions of the Earth in the orbit, elliptical orbit, you will come across the similar kind of points in the straight line. Now a point where the gravitational force of the sun as well as the Earth at that given location in that straight line becomes almost equal. You can say close to the equal. So what a small body, because sun is a very heavy body, I told you especially that 1.3 million times, and Earth is also a significantly large relative to the satellite mass. Okay, so the satellite will move in some kind of a halo orbit over there, and that point where these gravitational pulls are balanced. So if you see from that, within that hello small orbit or elliptical orbit, you can say, uh, then you will be able to see continuously the sun 24 hours. And those that point, such points are known as the Lagrangian. Lagrangian was a big physicist, theoretical physicist who did celestial mechanics, and he discovered such 5 points at least around the Earth. And generally, L1 is used to observe the sun, and similarly, L2 point is observed to see the celestial objects like stars, galaxies, etc. on the other side. L3 is, on the other hand, is the other side of the sun. So if you want to see at a given time on the other side, that is back side of the sun, and predict in next 14, 15 days what will happen on the sun, then you can use L3 also orbit. So similarly, all these different Lagrangian points have different importance for observation in the space. And you gave me big opportunity. Thank you very much, Professor Seema, the this RC1. Thank you very much, Executive Committee, and I say express my thank you very much to all of you. It is now time for your questions.
Thank you, sir.
Thank
Extremely
you so
good
much.
talk. Over to Poonam.
Yes, ma'am, you were saying something.
Actually, I'm to just mesmerized with his talk and the inputs he has given. He has given us the way forward to do small projects with regard to like greater height and depth and density and all these things matters. So we'll share your expertise, sir, in some of the projects that we'll do with the school children and college teachers. And thanks so much. It was par excellence. Thank you so much. Yeah, over to you, Poonam.
Thank you.
Thank you so much, sir, for your acuity. It is indeed a prestige to listen to your experience and knowledge. Thank you so much for a wonderful and insightful lecture. Sir, we are much obliged for sharing your insights and for endowing the young learners with your words of perception. Now, the session is open for the questions, and I would like to take permission from you to conduct the question answer session, sir.
Yeah, I'm ready.
Okay, thank you, sir. So first question in the chat box is by Professor H.K. Sejwani. He is very active member of IAPT RC1. He just wanted to ask, how do we ensure that during its journey to moon, there will be no meteoroid which may hit Chandrayan?
Okay. Because the speed of this Chandrayan, the rocket, when it goes and the mission goes, it is so fast. And whatever I mean, in the atmosphere, Earth's atmosphere, the small or even the bigger, this crashed down, almost become ash. Now, only that possibility which you are asking is when the satellite Chandrayan mission is close to the moon only, that is within the lunar orbit kind of thing. So lunar, that our Chandrayan 1 also did work very well. Chandrayan 2 is orbiter is still working. But the meteorites which are falling is of that not of that size that which can hit. And on the other hand, we already on the earth, we are having control power to do that thing. And you might have heard the term language manures, when we change the orbit, etc., to reach to the moon, etc. And similarly, the last manure you might have heard for the Aditya mission when it left the Earth. So we try to protect from that side also. We know the showers of these meteorites, and comets are always visible. The other thing, important question part of when the moon is there, on the surface of the moon. So there is no gravitational pull, there is no atmosphere. So the major risk is on the moon itself, that is on the surface. Just like our Chandrayaan 3, that lander and rover, they may get hit from this meteorites, etc., because there is no atmosphere to stop them. So large number of craters are being actually made by those meteorites, and so they may hit. So we may have put them at such a site, I showed that student has discovered the locations where the craters are very, very less. I'm audible?
Yes, sir.
Yes.
Yes, sir, you are.
Yes.
Okay. Thank you, sir, for the answer. Next question is by Dr. Rachna Kumar. And the question is, can you please tell us some key areas of research to which data fetched will be used?
I did not listen your question. I think
Yeah.
something you did on the. Okay, I think
Yeah.
just a minute, huh? Because in
Yeah.
my
Yeah.
laptop,
No problem, sir. No problem.
I don't know. Anyway, I am audible, right?
Yes, sir. You are audible.
Because some new windows are coming. Okay, so can you repeat the question,
Yes, sir.
Rachna, please?
Yes, sir. The question is, whatever data is fetched by the ISRO or the NASA, what is the key research area about that? Matlab, where we can use that data?
Okay, you can go to the ISRO site, okay, isro.gov.in, and for particular given mission, you can study, you can write even simply on the internet also, Chandrayan 2, Chandrayan 3, Aditya. You will find a lot of science objectives over there. You will see. And if you need, if you don't find, don't worry. I am there. I can send you the document itself. Okay. What are the science objectives? What are the physics gray areas, etc. But the data should be availability. Availability of the data is more important. And for that, from your university side, you have to write to the ISRO and get the data. Generally, there are many, many opportunities for the universities and university students by the ISRO. Okay, so my students in different universities, etc., they are also getting the project funded by the ISRO. It should be competent. I'm sure Delhi University is also very competent. I was under impression that you are already in tune with this. Anyway, so there is no issue related to the scientific objectives, science, physics issues, as well as data issues. Only you have to do little hard work to get approval and get the data. Yeah. Next
Yes.
question.
Yeah, the next question is by Dr. Vansh. Can you please discuss about how the lander of Chandrayan 3 changed its position after landing once, as video published by ISRO? Is this gives information about the atmosphere present in moon?
No, it was, you see, I told just now in the response to Professor Bijwani, he asked you see, I told the word manures, so we can do still enough power is if we have to use. So we can little bit now, not as orbit when it was in the air, but we can change its position of the lander as well as to the rover also. You might have also seen the video that we changed the position of the rover also. We stopped it because it was going to fall into a crater. Okay.
Yes.
We can always do from here on the earth. India has become very powerful country in the world. You see, we are flying the payloads instrument of other countries. Not only 104 satellites were launched by this country only, India, in one rocket. You see,
Yes.
that is also history.
Wonderful.
Yes, sir. Wonderful.
Okay. So next question is by Dr. Yogesh Kumar. He just wanted to ask, can the student of University of Delhi can do some minor project under your guidance?
I should have time. Only I told that I may visit 1 or 2 times only. I am very, very, similar like Delhi University. I have request from many, many universities, okay? And, but I always, continuously, I always get associated and I will try to share something with. We did with the Madhya Pradesh, you see, uh, one project, I think Riva, University of Riva, Avdesh Pratap Singh University, then in Bhopal also. And because we started our ISRO when remote sensing with the farms agriculture from the very poor, weaker area of tribal areas. So we still have focus on all developing states. And I mean, there is no, issue. I can give some projects to Delhi University students. Delhi University has many colleges. I believe Hansraj College, and there are many colleges, right?
Yes,
Under
sir. Yes, sir.
yeah, I think so.
Dr.
Yes,
Yogesh
sir.
Kumar is from the Hansraj College.
Professor Seema is from the Hansraj
I'm from Motilal Nehru
Motilal
College.
Nehru University. Yeah, Motilal Nehru
Yeah.
College also is there.
Right, right.
Yeah,
And
then
there are about 100 colleges in our
yeah,
Delhi University.
Arbindo was also there, no?
Yes,
Poonam
sir. I
Jain
am
is from.
from, sir,
Poonam
I am
is
from
from, oh,
Aurobindo
okay.
College.
Poonam is from Arbindo because
Yes.
I visited some colleges some 40 years back.
So,
Okay, okay.
so it would be very nice if you can suggest some of the projects for us, so so that we can work with our student and we can seek your guidance under that. Also, sir, Dr. Yamuna Shekhar is also can you please mention some of the research projects for the school children, which they can carry out?
They can make the telescope itself, you see, first of all.
Okay.
They should be able, you see, it is a hands-on experience. Hands-on experience, and there should be liberty. बच्चे तोड़ते हैं तो उनको पहले तो तोड़ने दीजिए. Allow them. You see,
Yes,
if
sir.
हमने
Yes,
सारे
sir.
हमने रॉकेट तभी बनाए जब सारे रॉकेट हमारे रॉकेट गिर जाते थे.
Okay.
That's wonderful.
आज
Okay.
आज आज दुनिया में सबसे बड़ा नाम है, तो हमने रॉकेट और दूसरी चीजें फेल्योर से हमने वी लर्नड ए लॉट फ्रॉम आवर फेल्योर्स.
Yes.
मेरी एक रिक्वेस्ट है सर.
And first of all, you see, without any facilities, without roads, as I told in the beginning, and with so many problems, and with a very low salary also. Okay.
Yes.
But, and
Yes, sir. It's
we
quite
could
motivating, sir.
we could do that. We
Yes,
could
sir.
bring the
So
ISRO.
the next question is by Dr. Krishna Saha. Sir, she is saying, as we know, the lander has been in a half sleep stage since a month now. Is it possible by any means to totally eliminate the sleep stage and still manage to work properly?
No, we did yesterday only. Since last 3 days we are doing, but yesterday we did lot of efforts. But you see the batteries, which are nickel cadmium batteries, okay, they reserve, they store this power for some days. But whatever the batteries which were planned, we thought that they will work for 15 to 20 days, etc. And in order to save their power, the lander as well as rover were kept in the slip mode. They were put up in there so that minimum discharging will be there. And now the sun has already come from 19th or 20th, I think. Okay, 20th of this month. And since last 3 days, we have been trying. ISRO information, as far as I know, yesterday's was that still, we have to do. So we have to wait. We have to wait for 1 or 2 days more. I think once the battery is charged appropriately, they will come into the action. Okay. Let us not get disappointed so early.
Yes, sir. So the next question is by Mr. Sauryadeep Lenka. He is asking, how does the coronal mass injection from the sun affect our Earth?
Yes, in 2 ways. Because there are two phenomena. One is the flare, the other is the coronal mass ejection. So the two things come out from this. One is the radiation of the order of few keV to the MeV side. Okay, that is very high energy radiations. So high energy radiation generally change the atmospheric chemistry. They don't penetrate all the way down because atmosphere itself absorbs about this 20 kilometer or something like that. But the other material, which is the charged plasma material, that comes all the way to the Earth. Okay, and Earth has a magnetic field. Earth has a magnetic field that is known as the geomagnetic field, and its geomagnetic field lines of force, they are connected from north and south, but because of the rotation and the wind pressure, solar wind plasma, that pressure, they are elongated toward the night side, and on this left side, that is toward the sun, they are compressed. Now, when the coronal mass ejections, that plasma comes all the way toward the Earth as well as to other planets also in the interplanetary space. But directed toward the Earth, it compresses, it compresses the lines of force, and the charged particles, while rotation, they go on the tail side, that is the night side, and then they enter into the poles, North Pole, South Pole, and the auroras that are produced, what you say, northern lights, southern lights, blue color, orange color, but we don't see in the India because we are near to the equator. But you can see in the European countries all this. I have seen when I was working at Pic du Midi Observatory in France at high latitude, you can see all this. So that is one kind of phenomena, but there are many other effects are there. Say, this potential current is generated in the atmosphere. Okay, electricity blackouts, etc., also take place. So then the climate change is always takes place. So there are many effects by this. So that is what we call as solar influences on the Earth. I have published one paper. Uh, if you want, I can send to you.
Sir,
Yes.
Probably this is the last question by Dr. Yamuna Shekhar. Can you please elaborate a bit about the eddy currents effect on Earth during the minimum sunspot activity and occurrence of earthquakes?
At the moment, as I told during my talk itself, not a better understanding is there very well. But what I can say that this eddy currents are generated when this galactic cosmic rays, high energy charged particles, particularly muons or something like of that energy, when they collide near the silicas, that is very soft, soil is there, or the soft soil, etc. And what happens that large potential is generated, big voltage, not million electron volt, tera electron volts. Okay, we don't know, but that is propagated along the lines of force down, and whatever the friction forces, that is to stop the earthquakes and volcanoes, that is tectonic plates which are there, and when they move, but now the frictions which is already there to stop them or to stop, slowly, that friction is actually affected. So the friction is, what I should say, friction force is reduced. Now, once the friction force is reduced, then the tectonic plates become activated. So the earthquakes come. This is what the preliminary understanding which has been generated over the world. I have not done any work on this physics part, but this is what I read, that this might be the one possibility. This is the eddy currents. When I'm saying when the galactic cosmic rays reach, that is already known. Galactic cosmic rays reach all the way down, not only even to the surface, but even down to the oceans also. But the eddy currents also may take place in the atmosphere itself also. So where is the catch? What is the real mechanism? Still, many secrets are there. We have to do a lot of work. Okay. If who is the questioner? क्या नाम बताया? Yashoda?
Yamuna Shekhar.
Yamuna Shekhar. If she is theoretician, if she has good theoretical background, then she can do that kind of work also.
Sir,
Yes.
On the behalf of the whole audience, this is my question. Does India plan to send a manned mission to the moon in future?
Yes, not to the moon, but in the space, of course. That is what that already project is underway. Yes,
Okay.
man. First robotic and then the man.
Okay. Okay. Thank you so much, sir. Beside
Thank
the
you very
questions,
much
I
to
can
all of
see a
you.
lot of remarkable appreciation in the chat box. Very informative lecture. It is very inspirable for the young generation. Very good talk. We have enjoyed listening to you. A lot of appreciation. I must say, not only on the Zoom, we have received a lot of appreciation in the YouTube chat box as well. So thank you so much, sir, for sparing your valuable time and enlightening our virtual audience with the insightful lecture. Very soon in the near future, we will have you in the physical mode with our audience. Now, without further ado, I would like to request Dr. Yogesh Kumar, the Secretary IAPT RC1, for proposing vote of thanks to you as well as to our participants. Over to you, sir.
Thank you, Poonam ma'am, and good afternoon, everyone. I, Yogesh Kumar, Secretary, IEPT RC1 and faculty at Hansraj College, honored to have opportunity to give a vote of thanks on this event. Today, I take the opportunity to put all my gratitude into words. On the behalf of entire IEPT RC1, I extend my hearty vote of thanks to the eminent speaker, Professor Rajmal Jain, sir, for taking out his precious time to deliver such a wonderful and informative session on Chandrayan 3 and Aditya L1. Sir, you have showcased amazing facts on successfully launched Chandrayan 3 and Aditya L1, and I'm sure that the participants have enhanced their knowledge in this area. Sir, your talk is quite motivating and encouraging for the participant as well. Thank you, sir, for sharing your wide spectrum of knowledge on Chandrayaan 3 and Aditya L1. I extend my special thanks to our ex-president, Professor VP Srivastava, and ex-officio Dr. OP Sharma for his timely support and continuous support and encouragement. I am very much thankful and grateful to our president, Dr. Seema Vats, for her enormous cooperation and guidance in the organization of this event. I have been very much fortunate enough to work with a team of motivated and dedicated member of IAPT RC1 and Hansraj College, Dr. Poonam Jain, Dr. S.K. Singhal, Dr. Surjan Sir, Dr. Manoj Kaushik, Dr. Ramni Kapoor, and the faculty of Hansraj College, Professor Sushil Kumar, Dr. Neelam Singh, and other members. I extend my sincere thanks to them for their help in organization of this event. Needless to say, I would also like to extend a big thank you to our audience for sparing their time and patiently listening to the proceeding of the event. Thank you all. Stay safe and stay connected. Thank you very much.
Thank you.
Thank you.
Thank you, sir. I think we'll organize a perennial series of this Antarish 2023 in near future with you, and we'll share each of your expertise on this subject.
Thank you so much, sir. We appreciate your gesture. It is very generous of you to spare your valuable time with us. On behalf of the entire physics fraternity, I thank you all. We appreciate everyone's presence in the event. We will see you soon with the great enthusiasm. Till then, stay home, stay safe. Thank you so much, sir. Thank you, everyone. The feedback link is already shared in the chat box. Kindly fill it before leaving the session.
And thank you, everyone. And can we wind up the session?
Thank you, everyone.
सीमा जी, मुझे आपसे एक रिक्वेस्ट करनी है।
हाँ जी सर।
वो आप जो है ना बायो सेंसर्स के ऊपर इनका एक लेक्चर जरूर करवाइएगा। I am very much interested in this biosensor, learning about the biosensors and other sensors also.
Yes, sir. Yes, definitely. Thank you, Ramnik ma'am.
Anji, thank you very much.
नहीं sir, बिल्कुल. I was just thanking Ramnik ma'am to take out the precious time. Yeah.
Today I could attend, wholeheartedly without any commitment from my organization. So I'm thoroughly, brushing up and really great. Thank you, everybody. Thank you so much.
Thank you so much, ma'am, for sparing your time.
My pleasure.
Nice to see you.
Yeah. ठीक है सर, शेजवानी सर बिल्कुल बायो सेंसर्स पे हम अगला करा लेंगे और मोस्ट प्रोबेबली ऑफलाइन रखेंगे और ऑनलाइन भी देखेंगे मतलब
Okay,
देख
thank you,
सकते हैं।
everyone.
थैंक यू पूनम, थैंक यू योगेश। ओके।
Thank you, ma'am. Thank you, sir.